We're just getting started. We're going to let a few people roll in here as people are getting connected. Thank you, everybody, for being here. What do you think, Brandon? Should we get started?
Let's do it. So I'm Brandon Leiran.
Yeah, I'm Joe Schneider.
And we are going to get right into it. Like Joe said earlier, if you have any questions, go ahead and put them in the chat and we will pick them up as we see them.
Yeah, cool.
We are going to talk about CI for embedded. We're going to get started right away with 15 years ago, Joe and I started at a new company and got put on a project that was already in flight. We had an architecture already and teams established. So there were 4 repositories with different things in it. You see a BSP, some core libraries that were used by a couple different apps. And I'm guessing that you probably know how many teams were involved with the project based off of that. There were 4 teams involved. And the first thing that kind of our onboarding said to do was go ahead and clone each of these 4 repositories and build the software. And Joe, what happened when you built the software the first time?
It was terrible. It was a terrible situation. Yeah. Part of it had to do with our version control tool at the time, but it was, you never knew whether it was going to build. People were changing interfaces all over the place. We did a pretty good job, I think, at the time of trying to isolate interfaces, but still, it was just really easy to break things. And not only that, but it ended up getting compiled into a monolithic, executable, and that sometimes the linker didn't sort things out right. And sometimes it compiled and linked, but then when you ran it, it crashed. And so then your only option was to do a big rebuild. We were working in, this is silos, right? We were working in a siloed environment where everybody kind of worked on their own and, kind of foreshadowing, we were not continuously integrating.
Yeah, I know for me, the normal pattern in the group that I was working on was to not even go out to source control. We use source control. I was working in AppG for AppG, but for the rest of them, we had zip files that were passed back and forth because then we knew this version of BSP, this version of the core libraries would work for AppG. So it was really chaos. And when I say zip files, I mean, it was like you talk to your neighbor and your neighbor was like, yeah, this one worked last week. I think it's still working. So I think it was Joe that came up with the idea of a continuous integration tool based off of that need. And at the time, the tool isn't that important, but at the time, it's a tool that's not around anymore. And I guess Joe.
We use a tool called Cruise Control, which was out of ThoughtWorks. There's, ThoughtWorks was kind of a little bit of a leader at the time. Martin Fowler, I think, was there at the time, and he had. I think they were building this culture. The agile stuff had kind of started in the 90s, and it kind of flowed into the early 2000s. And they had the vision to build it internally, and they also had an inkling towards open sourcing what they had. So they had open sourced this tool called Cruise Control, and it was a pretty basic web page with some, roughly like a glorified cron job, able to automate something on a schedule and check version control. So it was kind of, I guess I haven't looked at the whole history to see if it actually did contribute code into Hudson, which then became Jenkins, but I wouldn't be surprised. It was an early on Java app that was kind of starting to, become the tool, or was one of the very first tools I'm aware of that was doing CI automation. So yeah, I got that running on a laptop because this is like rogue IT. I'm sure some of the folks here who work in corporate environments, sometimes you just need to set up a machine under your desk and hope nobody notices. That's kind of what we did, because it was just like it was a problem that was hitting us daily to know whether the build worked, and just the conversations over the cubes. It was just like, hey, does the build work for you? Because I just did a compile and I hit compile 20 minutes ago or 30 minutes ago, and I finally got an executable and it's crashing. Is that what you're getting? And so that's, that was kind of the impetus where I was just like, geez, I just need this for myself. It was a crappy laptop. Once I set it up and started working, the fan was running probably nonstop because it was, just like crank and compiling code. And it had, I guess, the network wasn't quite locked down as it might have been today. And so I was able to send the URL to the web status page to other folks in the team, and they were able to get it. So it was kind of like a select group of people. It was very much a grassroots effort, a select group of people that I was like, hey, check this out. Like, is this cool? Is this valuable? And then eventually kind of worked that up to the department manager and others. And I think at that point, it was clear that it had a lot of value.
Yeah, we'll come back to this a little bit, but kind of, I would say in the first 6 months or a year, kind of the result of being able to get that nightly feedback and seeing initially how often it was not working together really led to the 3 repositories on the right being combined, so that there was more both technical, I guess, working together between the different parts of the code, and also the teams working more together. So it was very valuable to get that feedback and show what everybody kind of on the team knew, and then got the architecture group and the leadership to buy into the idea that it was not working the way everything was set up. So that's really the way that I got introduced to continuous integration. Joe brought in a tool and kind of, like he was saying there, grassroots, spread it throughout the organization. And really that was how I got started in continuous integration, which we jumped right into it, but I really like this definition from James Shore. We keep our latest code ready to release. So we just talked about an example of, we didn't even have any signal that was telling us whether our code even compiled altogether. So we'll talk a little bit more about the continuum here in a little bit, but as we're thinking about continuous integration, the concept is really pretty simple. The code that I'm working on, the code that Joe is working on, the latest hardware that it's supposed to work on, do all of these things come together in a do we know, and are they ready to release right now? And it's really a pretty big challenge, especially in the embedded space. I threw in hardware there, which is a little different than a lot of other industries that that have environments that they're running their code in, for web, for example, but they have a lot more control over that, and it's a lot more abstracted than it is in the embedded space. So continuous integration for me was really the kind of gateway drug into Agile and extreme programming. I'm not going to go through the whole thing here, but the kind of the concept I want to pull out for continuous integration is that in Agile or XP, being able to take your work and to segment it into small enough pieces that you can get feedback on it, and I mean feedback very generally, is extremely important. So continuous integration is a way to get some of that feedback through an automated system. And a lot of the other pieces in Agile really don't work unless you're getting feedback and taking action based off of that feedback. So as we're going through this, I want you to kind of take what we're offering as our experiences and look for stepping stones that will change your work. If you don't change how you work or your team is working, you're not really getting much from this, because the improvement pieces are really, they're hard to do because they involve both people and tools. But I guess just looking at the textbook examples to me is not that interesting. So we're really going to try to share a bunch of our stories that and experiences along the way. Not all of them good, most of them good, but not all of them good. So I guess an example of that, and I put mind the people here because a lot of times when people talk about continuous integration, the focus is really on the tools. You hear people say Jenkins a lot, or GitHub or GitLab or Bitbucket when you bring up continuous integration. But as important, or probably more important, are the people. One of the things, an example of that is one of the things that after that project that Joe and I were working on, after we got an automated build for it, and you could go out to the web page and look at the current build and see if it worked or not, see what errors you had, and download that. A way that we found, and this was something in Agile, they talk about big visible information radiators, is to make it more, I guess, obvious to everybody when stuff is working or not. So we set up a monitor at somebody's desk, put it on top of the cubicle, and put a dashboard up there of I think it was like the 10 most important builds. And it was just rows and columns basically. And the cell was green if it was currently passing, or it was red if it was failing. I think we actually made it kind of a pinkish, just because it was funnier looking. But then, as you're going to the break room or going to lunch, you could see, oh, something's broken. I wonder what it is. And it caused a lot of conversations to happen. But within the team, I think they were all pretty happy with the changes, understanding them. But we did have one instance that Joe can tell us a little bit about, where the people didn't really like the tool.
Yeah. So I think Brandon and I both remember pretty vividly. We worked at a large company, Fortune 500, and there was a time at which it was 2 levels up manager was walking through preparing the building for a visit from somebody from corporate. This is like a senior vice president in the organization was coming over, and a large industrial manufacturer. It's they're very familiar with big dashboards in the factories. Like there's you see a big red light or a green light, and those can mean like a certain station's up or down. And so. But he hadn't really critically evaluated our dashboard until he was doing a tour through to prepare for the senior VP, and he stopped and he's like, "What is this?" Because there were some builds that were red at that time, and he's like, "We can't have a big dashboard that has reds on it for this senior VP to come through, right?" And so it was very interesting to just. I think we were all maybe for the first 10 seconds dumbfounded, like, what do you mean? Like, this happens like every day, we get it it's a little broken, and then we fix it, and I think how we ended up resolving that was putting a little like explanation next to it that kind of said, like, this is what red means. It doesn't mean we're like factory down or, like production down. It just meant that we, somebody checked in something that broke the build and we're working on it and fixing it. And that happens multiple times a day. And I think just that, I think kind of playing back to Brandon's theme about, minding the people, I think understanding what baggage do they come with, what context do they come from, what might their expectations be. And that's a big part, I think, of making a CI initiative successful in an organization is really, caring about that and minding that it's not just about forcing a tool on a team or a process.
Yep. Yeah. Yeah, I had forgotten, like you said, I forgot how we resolved that. I thought we just talked, but you're right. There was a kind of a key. It
was really kludgy too. It was like a piece of paper that we duct taped on or something. I don't know, maybe scotch taped on. But yeah, and that I guess was good enough. I think, there was some compromises happening there, but yeah, it was, and I think that was one of the first times too, where I was starting to recognize too, like, wow, like we do have some power here, I think, and to change the environment, to change expectations for people. It was, I felt kind of empowered after that, I think, just to like, wow, like people are paying attention. This is working.
Yep. Yeah. And you mentioned kind of the culture there, as a big iron company, and I guess in embedded, a lot of times we have hardware, also, and some people who are more familiar with that process don't understand how malleable software is, like you said, and how builds do break. It's just a normal process. The more feedback you're getting from your automated process, the more likely it is to shows some instabilities.
And Kyle's saying in the chat, like, this still happens. Awareness combined with knowledge is important. So thanks, Kyle.
Awesome. Yeah. We'll talk about ADKAR a little bit later too. I just wanted to bring that up here because ADKAR is a change model process that I found very valuable in working, in organizations. The idea is that if a change is going on, first you need to be aware of it. You need to want to do it. Then you gain knowledge. Then you have the ability to implement it, and then reinforcement continues. So, like I said, we'll talk about it a little bit more later, but I wanted to bring it up because I'm hoping that some of our stories and the information that we're sharing gives you some awareness and a little knowledge about how continuous integration can work in embedded projects and software. So I said we were going to drop a lot of stories and personal experiences, but before we get into those, I also wanted to throw this out there for the people that are maybe a little more analytical, or if your boss is a little more analytical and looking for, I guess, some more research-oriented surveys. The Dora project, which is now sponsored by Google, part of Google Cloud, is a research project that started 7 years ago. They survey people on what practices they're using, and then also what results they're getting based off of those practices. And I'm not going to dive into this too deep. I included a link here, but if you just type into Google Dora DevOps, you'll get there pretty quickly. There's also a book that really goes into it a little bit more called Accelerate, which is very cool if you're interested in it after looking at what Google has out there. But the idea is that practices like continuous integration lead to more successful projects. And some of the things that more successful projects have are more frequent deployments of code. They're able to get from committing a change into their source code repository to deploying much, much faster than poor performers. They're also able to recover from issues. And they also, when they do make changes, have less failures. Like I said, this is a pretty cool, if you're into data, this is a really cool thing to go look at because they have so much data and how they work on the correlations between the practices people have and then the results they get out of them. So we talked about the James Shore definition a couple slides ago, but I wanted to dig a little bit deeper into what continuous integration means, because it's saying something is releasable is pretty simple, but there are two aspects that I like to think about. One is on the x-axis here is that when I make a code change, how often is it merged with everybody else's work? So if you are working on a project and you're in a branch for 6 months or whatever before you merge it with everybody else's work, then your merges are every 6 months, or in this case, I said every year. If you are on a project where everybody is merging their code daily, and this is called trunk-based development because some people actually do this even in larger projects, then you're farther over to the right. You're more continuously taking your work and putting it with everybody else's work. So another aspect, though, is how often are you getting feedback on that work? So we talked about using cruise control or a CI system to take your automated build or whatever feedback you're getting and sending you an email, making you a web page that's telling you what the results are. There's a lot of options there, but once I have a change and it's merged with everybody's work, do I get feedback in months? And this is because either I don't have an automated build, or there's a lot of manual testing involved, that sort of thing. Or do I get feedback in minutes, meaning everything's automated and everything is extremely fast. We're going to talk a little bit about some terminology coming up, but if you're way up here in the right-hand corner where you are continuously merging in your work and you're able to get feedback in minutes on that work, then that's the point where if you want to release it to your users, it's a business choice and not a technology choice. But there's a lot of effort that goes into that. So I wanted to talk a little bit about continuous delivery, continuous integration, and continuous deployment. Sometimes people use these words or phrases, together, and are trying to mean the same thing. They're really just different different degrees of what we've been talking about. So continuous integration means that you are taking your code changes and putting them together with everybody else's, kind of the x-axis that we talked about over here. So the more you can continuously integrate, the less people are working off in their own things and adding, potentially risk to the system. Continuous delivery is taking that a step further and saying, not only are we merging our stuff together, but we are continuously testing it. We're validating it that, at different levels, unit, component, production environments, in the embedded space, Hill, or even, some of the manufacturing type tests are being done with our code changes. And the delivery is from the aspect of the team working on it. And then continuous deployment is one step further. It's saying not only are we putting it all together and testing it and validating and verifying it, but we are actually pushing it to production incrementally. A lot of web applications do this in like a staged manner. If it's a large scaled application, like one of the canonical examples is, you might be looking at Facebook and somebody else might be looking at Facebook and see different things. And that's because Facebook rolls changes out and hits a small population, and they're doing that all the time. Facebook maybe not a great example because they're kind of famous for breaking things, moving fast and breaking things. But this idea is that, that there's a lot of value for some products. You don't usually see it in embedded, but you do see it in a lot of other areas. I don't think we talked about this, Joe, but I know in the past you've mentioned Tesla and what Tesla does on this spectrum.
Yeah, I mean, they're kind of a love-hate example sometimes because they certainly, have they end up in the news for reasons I don't love sometimes. But they certainly, I think it's unquestioned that they have pushed their industry forward. And there are other examples in other industries, but the idea of continuously deploying safety critical firmware that is can affect somebody's livelihood, their life, and then doing that in a regulated market, that I think a lot of people just stopped at that at first face. You're presented with that problem. If you were in an industry that was, I think we even kind of talked about that at some points in our industrial, environment, and it was like a non-starter almost. I think, especially early on, like, why would you ever do that? That's a huge liability and risk. And I think, at least, for all of its good and bad, I think at least Tesla has really shaken up the industry, and now Ford and GM and others are doing it too, right? But it's because they've seen the value. And I think that's one of the fundamental things that why at Dojo 5 we're so interested in pushing the industry forward, is because I think that same scenario is going to play out in many of the existing industries, if it isn't already happening in many industries. And I think the companies that are leading that charge are the ones that are going to be best positioned to be successful in the future. Because I don't think firmware complexity is not going away. And so the visibility that we've been talking about up to this point, understanding the process and tools that put you in a position where you can release whenever you want as a business, like Brandon kind of said, it's a business decision, not a technology decision, or not you don't have to run a program and wait for months or whatever it might take to get a bunch of features out the door. It's just like, well, we've got something ready to go today, and we'll have something else slightly better ready to go tomorrow. That has changed the game. I mean, at this point, Tesla and I, maybe possibly other cars, but I mean, like you can add on services in the car. There's like a, whatever, buy ludicrous mode for $10,000 or whatever, right? Like who does that? That's kind of wild. But I think also it really changes, and this is kind of going maybe a little higher level than this slide was intended, but it really changes the game as far as the relationship that you have with your customers. The idea that instead of just I buy this, retail device at Target or something, or I, buy this device off the internet, and then and that's my only interaction with your company. And at that point, it kind of just does what it does. And if I want something new features, if I want, then I have to go buy a new one. That breaks for a number of reasons, right? When other companies are able to maintain a relationship and bring ongoing value to your product, that I think is a game changer. It makes your products, it distinguishes you in a way that other products aren't. And I think then, the number of devices that are ending up on the internet too, there's a security piece to it too, where it's just it's becoming required. If you're going to be on the internet or a connected device, you have to have the ability to update and, for people to have a reliable and secure service. And that's, I think, also is driving a lot of the complexity.
Yeah, the expectations are definitely changing as more embedded products get integrated in bigger software systems, including web and other things like that. Okay, we are going to kind of transition here and talk about, I think, 4 different steps that you can take to start moving in your CI journey. So everybody's going to be at a different place, in this spectrum, about merging your code and keeping it integrated, person to person, release to release, and also your feedback. But these are one way that we feel like if you don't have this, you should start here. So we've talked about this already, but change is hard and people need to see why you're proposing things instead of leading with, hey, let's agile this or let's tool this. I think it's really important that one of the takeaways you have here is start thinking in your brain. If your group or your team is not used to doing retrospectives or, sitting down and doing those reflections and what to do about them, then you can just have it in your mind as things don't go right in your day-to-day life, either from a product perspective or, people are unhappy with the tools. Just kind of start writing those down, either actually or, in your brain. Hopefully some of these things sound exciting to you. What delays integration in your system? What is missing when, a bug goes out the door? How could we have gotten feedback on that sooner? Those sort of things. And start sharing those with other people, that are interested in making life better and your product better. One thing that I think about with regards to this is that I can think of a lot of bugs that happened and defects that happened that nobody went back and thought about this, and it's really a mischance. One in particular that people did see that I experienced was we had a hotfix that needed to go out on a particular controller, and the hotfix was actually pretty simple code wise, and it was made very quickly, in a matter of a couple hours, and started testing and seemed to be working functionally. But after it got more manual test time on it, there turned out to be some weird boot up issues, and the system just kind of went haywire every once in a while with the hotfix included. And days were spent by our team looking at why this very simple hotfix was not working. What it turned out was that this particular controller didn't have CI set up, didn't have an automated build on an independent system, and it was a weird version of the compiler that was off by, I believe it was like a version of the compiler that was the same version number, but it was actually a little different. And so when they figured out that it was so-and-so's desktop was good and the other person's desktop was not good at building, it led to getting enough priority and awareness to giving people awareness and then giving them priority to go fix the issue.
Yeah, hopefully somebody can use that story to help accelerate organizations, so we don't have orgs don't need to learn this lesson through trial and error or failure. And that's, I think one of our goals is hopefully that, you can take away some ideas of like, yeah, you know what, we're kind of at risk for this. I see an issue where, we're probably susceptible to this. And then you can bring that back to your organizations and say like, hey, like I've heard of other organizations where this particular thing actually did happen. And it was like, let's get something like CI in place so that we don't have this issue happen at our place.
Okay, so we talked about step one, just be aware of the people and make sure that you're solving a pain issue that people are having in the product or in their workflows. So this one's a little more nuts and bolts. If you don't have an automated build, a good way to start is either when a new developer is starting, make sure that kind of do an audit, sit with them and say, if you have onboarding docs, this is how you get your computer set up, and it's got all of the requirements, all the tools you need to install, the SDKs, everything. And as they're going through it and they find holes in it, jot those down. So make sure that you have, like, a person could do this if they step through it in an automated way. That's kind of the first step, because the team that I worked with, and I think you said Kyle was maybe online there.
Mm-hmm, yeah.
We did work with other teams that that wanted to improve their CI, and this is one of the first steps we always did. And typically, teams either didn't have onboarding docs, or they found out that they were way out of date. So before you try to go all fancy and script things and all of that, just make sure you have everything identified. What you'll find, that hopefully what you'll find is that there's a lot of those steps in there that you can automate. Most of the tools, IDEs or SDKs out there today are going to support automation. In embedded, one of the things that we've found is that even kind of old school compiler vendors are starting to move their tooling to either be able to run, not through the GUI, and be aware of build tools as like separate from a developer tool workflow. So that's something that I think even 5 years ago you wouldn't have necessarily seen, and you would have had to fight more through. It's still not maybe the easiest thing, but it's definitely people are aware of it in the industry, in the tools industry.
Yeah. And just kind of doubling down on that, I think that's been part of some of the issue, I think, is that we've, in the embedded space, we have tools that we've been using for 20 years sometimes, and like they work great. Why change? But at the same time, they weren't designed in a world where we had as complex of firmware as we have, as the same market forces that are at play, the same expectations for these devices. And I think, those manufacturers need to change too. And we hope to, be a guide and an assistant to a lot of those groups. And I hope that we can, help to push those forward. I think, as Brandon mentioned, a lot of them are starting to hear frustration from their clients. So like if you run into that, you're using a tool, it's key to building, or testing or whatever, your device, it's ingrained in your company. You're probably going to have trouble changing the tool out wholesale, but you might have, I think it's worth it to bubble that up to those companies and say like, hey guys, like we need to be running this in a CI system, and your tool doesn't allow that, or has a really crappy CLI, interface. Like here's what we need. Can you help us build this? So I think that's the pushback that some of those vendors are going to need to really like put sales on the line to make to force them to kind of innovate.
And then the last step here, is to take what you've learned, both about what the problems are, what the pains are, and some of the automation that you see that's needed, and combine those together and work with whoever is scheduling your time to say, we need to improve the way we work. And that needs to be thought about in the same conversation on the product work that we're doing, because our goals involve different aspects of quality, different ability to react to changes, whether it's a new feature coming in or a critical defect that needs to be turned around quickly. The way that the team works is really important for those business goals. And this is really the step where you're taking it from something that's probably pretty low cost, going through and making sure you've got stuff documented for your build is pretty low cost, and two, you're going to probably have to spend some real time on getting your automation going, depending on your tool chains.
We got a question, but I think I'm going to save it for next slide. So
okay,
I think we're almost there. Why don't you introduce this, then we'll jump into it. Thanks, Graham, for the question.
Yeah, so we really are huge advocates of doing your automated build in the cloud, meaning take what you've got in your repository, probably Git, and most people are using Git, I think. If you're not, there are other options out there, but Git is kind of the main one. And use a software as a service for your version control and your CI, like Bitbucket or GitHub. Or some people have internal IT that offer services that are comparable. Everybody has different, I guess, experiences with their IT teams. I'm talking with some of our clients. They're pretty happy with what their IT provides. In a lot of cases, it's not the case. And I think that the receptivity to using like a SaaS has improved a lot, even in the embedded space, as people are, connecting their embedded devices up to the cloud, and then so they're already in AWS or they're already in Azure. So a lot of those reasons, there's more receptivity even in big IT shops to using like a Bitbucket or a GitHub. Really, the goal here is to get regular feedback with the lowest cost to you and your team. So Bitbucket, GitHub, these tools are, I would say, very featureful, and you don't have to manage them. You don't have to operate a web application. You don't have to operate necessarily your CI runners that are executing your build. So your maintenance load is a lot lower. And especially when you're getting started, this is at least where I would propose you go and try this out first. Even if you end up with some different solution, like an on-prem solution with Jenkins or whatever, I think you're going to get a lot of value out of seeing what I consider a commodity CI provider like Bitbucket or GitHub or GitLab. So
this is the equivalent of what I did 15 years ago with a laptop, right? It's just that we had our stuff hosted internally. And I think that the low-hanging fruit is to host it externally. Sometimes that's not an option, depending on your environment. But I think the industry is headed that way. I think there will always be some larger companies that are just, or sometimes regulated industries that are just like, our code has to stay internal. But I think there's so much benefit in IT companies. I mean, people see it on the bottom line to having a software as a service, VCS and CI service out in the cloud, that it's just, I think economics are going to drive majority of the industry that way. And there will be some laggards for sure. And some people that never move, but yeah. One thing so Graham brought up the question, what are your thoughts on for having CI like directly on a build machine, like bare metal, like something like Jenkins running on a Windows machine or something, versus using containerized systems like Docker?
Yeah, so I was talking a little bit earlier about the challenge piece. So I think there's a ton of value in getting your build environment in a containerized system like within Docker. It allows you locally to build in the same method as you're building on your CI system. It provides a way for you to back up your whole environment in like a big chunk, instead of relying on tools and a bunch of scripting to get your environment set up. You've got it in a big chunk. but there is definitely some challenges related to that. A lot of people that we work with, for example, are using compilers in their IDEs day to day in Windows. Most of the service providers either don't support building in a Windows container, or it's kind of a second class citizen in terms of performance. So we do have, experience with compiler vendors and using, the Linux version of their tool chains to do the builds. You can also then do those locally using Docker, but it is a change to workflow, and building those Docker containers and maintaining them is something a lot of embedded teams don't have experience with.
Yeah, and that's honestly what we hear a lot from folks when we talk with them about getting started on CI. Is that like they've got some great embedded engineers internally, but like most embedded engineers haven't hit Docker, or maybe they've heard of it, but they're not Docker experts. They're not like Bitbucket, GitHub, GitLab, other providers all have their own like domain DSL, like the domain specific languages. A lot of times it's a YAML script, and there's a new format to figure out. There's new keywords. You're reading through reams and reams of documentation. And then on top of that, like I'm using this compiler vendor that hasn't modernized, and it's tough to use from the command line. And now I got to figure out like a Python script or a Bash script to like glue this stuff together. And there's it becomes this giant science project. And that's, I think, where we've seen a lot of folks get stuck. They're like, I know the benefits of it, and I want to get CI in place, but I don't have time. Like I've got 10 other projects I'm supporting. I don't have time to go on a science project run and try to like figure out all these pieces. And the crazy thing too, I think that we recognize is that there are only a handful of compiler vendors, well, maybe, I don't know, a dozen compiler vendors right out there that are frequently used in the embedded industry. But I would bet that there are probably thousands of instances of these like Python scripts and Bash scripts getting built in custom environments, across the industry. And it's silly to have us all like working on those over and over and over again and refining them. And that's, I think, one of the things that we're trying to like bring together a group of people and attract that group of people and really kind of and push the industry forward through ideas like let's commonize on what those are, and let's just kind of get that piece moving forward, because it's dumb for us to everybody gets stuck over and over again at the same spot. So yeah, and I would just reiterate too on the container systems like Docker. It's that's our intern. We always head towards Dockerized containers. We have all of our builds, and that's we believe that's the way forward. And I would say too, like some people go out learn about Docker. Docker recently changed some licensing things that sometimes get people scared at larger organizations. The open source community is awesome, and they're already kind of innovating around that, things like Podman or other different tools are really making it so really we can just talk about containers. The container technology is not going away. It's not going to die with Docker or anything. It's here to stay. So there are ways to move forward, even with Docker kind of being the bastion and being setting the flag and really pushing the industry forward in terms of that, but then kind of needing to make some money, I guess, eventually as a company. So, but there are ways around that too. So don't let that stop you. I was going to say too, Fran had just a comment about clearly remembering trying to make a cross compiler that it was thought to work only under Windows environment, working on a new CI on Linux, and it had like a no window flag. So it could be run from the command line, but of course it still needed X Windows. I don't know, dynamically linked to X Windows code or something, right? So it was his comment. It was really a nightmare. And yeah, I think a lot of the tools have weird situations like that. You're trying to like run an installer. You're trying to run, like some tool that really doesn't need to be a GUI, but it happened to have a GUI attached, and now you got to figure that all out. That's the kind of stuff that we think, again, like the industry shouldn't be doing that over and over again. Everybody who uses X tool just figuring that out on their own. It's silly. Let's group together, band together, and push CI forward. Thanks, Brandon, Graham, too.
Yeah. So I guess the kind of the end stage here is, using your CI builds then for feedback. And a lot of teams we see do that as on a daily cadence to start with. One of the reasons for that is just initially there might be a lot of negative feedback. You might get a lot of failures that people aren't used to the code being compiled that often, and they're checking in stuff that isn't ready to go. So it's a good way to know what the current state of the code is and get people working in a different manner to kind of get to that continuous integration point. And there are definitely some arguments that might happen there about, is this really valuable? And I think you need to go back to your pain points and show people, there is a lot of value in this. And eventually you want to get it so that you're getting that feedback on every push, and then actually being able to release your production releases from that process. And a lot of times there's extra tooling that's involved with, creating your production ready binary. And I think that's really important, but I put that after because I think a lot of the value here is in getting that regular feedback.
We wanted to chat a little bit here on just Jenkins. Jenkins has been an awesome gateway drug, I think, for people to get into CI. And in some cases, even where Brandon came from, it's used in production in very large scale. But there's, I think, Brandon, your message was just, it's not a fun side hobby, and maybe dig into that a little bit.
Yeah. So the reason I say that is that, especially in a lot of the environments where people kind of lean towards it and think that it's an easy tool to get up and going, you end up with having a lot of issues with keeping it operational. So it's a Java application, so you need to keep your Java versions up to date. You need to keep Jenkins up to date. If you're not really, really disciplined on your use of plugins, you need to keep those up to date. So you have a lot of functionality issues from that, and you have a lot of security issues too when you're not on top of all of those things. The other thing you're losing is a lot of the batteries included pieces you get with like the GitLabs of the world, where they have a lot of tooling built in that Jenkins doesn't provide out of the box, and you probably don't want to add on with the plugins. Even simple things like having a Docker registry provided, things like that are really super cool. You have to bolt on top of that. So especially in the case where you can run, if you cannot go out to the public cloud and you have to be on-prem, you can use a tool like GitLab internally to, they have an open source version that has most of the features that you can get externally too. So I would say start with that.
Yeah, it's a great option.
And then another thing that I would say is the external SaaS products also have really upped their game in being able to allow runners external to their system. So, if you really needed to, like for hill testing, for example, if you needed to attach your computer, your Pi to some physical equipment that you have on site, you can get a runner from your CI provider that will then allow you to interface really cleanly with that external SaaS service, instead of saying, oh, I have to do this internally. That's not necessarily the case anymore. Okay, I'm going to skip this one so we have at least a couple minutes left at the end. So I put number 4 on where to start as automated testing, which really pains me because I'm a huge fan of automated testing. But I'm just going to dive right into my experience when I joined a company many years ago. That really is this last one. You have to have your automated tests integrated into a CI pipeline for them to stay healthy. I joined a team that was pretty mature. There was requirements for automated testing, but we didn't have automated CI pipeline feedback. I was handed a go make this big chunk of code work. It's all implemented and it has all these automated tests. And sure, it compiled, but when you actually tried to build the automated tests, they didn't compile because that was kind of an add-on. And then even looking at what the automated tests were trying to test, they weren't actually testing the functionality. So that's automated testing, especially when it's done, not from the beginning, can be extremely challenging. And if you are going to jump into it, I really think you need to have your CI pipeline set up and ready to keep giving you feedback on its applicability. Unlike your build, some developers might not run the tests locally, and the CI pipeline is really where that needs to come out and show you, hey, there's this quality signal that's failing, that if it continues to fail, we need to be explicit about it. We either need to keep it or fix it. And yeah, definitely use an off-the-shelf framework. And there is also the challenge here of you're probably going to need to do a host-based build for your host architecture to run those tests. Those are both challenges. And the kind of the book that I put down there, there might be a better one. This book, I didn't even realize. Is it still the best?
Yeah,
it's been around for almost 20 years.
I know, that's ridiculous, isn't it?
Yeah, it's a great book. It's called Working Effectively with Legacy Code, but he
has a terrible name. I don't know if Michael's ever heard that, but I feel like it sounds so boring, but it's actually really fun to read. It's organized well. He's a cool guy. He's a funny guy if you've ever met him in person. And it's well organized. It's easy to read, and it tells you exactly what you need to know.
Yeah. So if you haven't checked that out, like Joe said, it's great. And a lot of it is about how to get your legacy code or code that hasn't had tests, as it was being developed, how to get tests put around it in a safe manner.
Yeah. I love legacy code. He defines as any code that doesn't have tests. Doesn't matter if you built it yesterday or 2 years ago or 10 years ago. It's just, if it doesn't have tests, it's legacy code, which I think is a really cool definition.
Okay, and we are wrapping up now. We might have a chance here at the end for a couple questions, but I just wanted to end this with what Joe and I are thinking about and working on. I think this is a good way to say not everything. We don't have everything figured out, and we're looking for and finding really interesting problems. We talked a lot about this first bullet, the making your build pipeline, your CI pipeline, kind of a easy to set up and maintain sort of process. Joe and I, we didn't really go into our sales pitch or anything, but we both work for Dojo 5, and this is one of the main things that we're doing, in our day job is trying to make it easier for a team to get onboarded into a CI pipeline. Specifically around the build is where we're focusing now, but other quality processes, along the way. One of the interesting things that we're starting to hear more about is securing a supply chain. So having software bill of materials, there's a lot of like education, or not educational, like research oriented work that's been done with that. And the DORA study, one of their key findings in 2021 was that more people are starting to look at this. We mentioned Docker. Joe was just pointing out the other day that Docker is starting to add some alpha tools for, taking the Docker container and ripping it apart and telling you exactly what's in it, so that you can, trace your supply chain and what is all involved in your tests or in your build environment. So that's another cool thing that we don't have figured out, but I think is coming down the road. Some of that'll be regulatory, but I think a lot of it'll just be, we want to do the right thing and make our embedded projects secure. And the last one is hardware in the loop, which is a really big, cool topic that we will be talking about in our next webinar that's coming up with Ander and Joe I guess it's in about a month and a half. So
no, in a couple of weeks.
Okay, in a couple of weeks.
Yeah, 28th, July 20th.
Oh, we got the wrong.
Oh, it says
date on
August
here.
on there.
Jeez. So this is right. It's the July
There
date.
you go.
So I guess with that, I have not been following the questions, so I will jump in here in the chat. Was there any, Joe, that we should
No, I think
pick up?
just
Brother?
Fran had kind of reflected again on kind of sticking it to the vendors, just make sure you just, I mean, not in a mean way, but just like if they don't hear any feedback, then they kind of assume that everything's working fine. So, and I think that complacency in the industry has slowed down adoption of modern tooling. It just makes, when an engineer's got 10 things on their plate and one of them CI, do I spend, 2 days figuring out how to script this tool from 20 years ago that we need to use, but it was never intended to be used from the command line, or do I just skip it, and we run it manually and we never get to automate? So I think that's a just really good thing to reiterate. Any other questions that folks had? Just got a couple minutes.
Yeah, so I see Fran did ask also in the Q&A about hardware for validating the behavior of the system. Is that a typical thing that you do? And then how does that affect your feedback loop? I think that's a good question. So I'll make the cop-out answer and Joe can give the real answer. One of the reasons that I put Hill on the we're figuring out piece and not on the first 4 steps I think you should do is that Hill is hard in terms of getting it configured and making sure that you're getting valid feedback. So my push is always to take as much as your business logic and things that you can abstract away from your hardware and test those in the host-based kind of unit software testing. I
mean, you ran a large hardware in the loop system. So you would, just like you've had direct experience with this, managing that for years, and the costs and the issues that come around it. So yeah,
there's a ton of value in having those systems and having them for things that are related to actual voltages and sensors and that sort of thing. But I think you want to leave that for your Hill and, like I said, test as much of your business logic and just application logic in general without that, because that is complex enough. And I think Hill is the next step after you've got that stuff nailed down.
Cool. And then Graham just threw in a question. Hill is what I'm currently looking at. Are there any frameworks for this like there are with unit testing? So I would say the pattern we see over and over again at companies is they automate for whatever reason with PyTest. So I think there's some level of acceptance that Python's been around for a while, and PyTest test is intended to be like a unit testing tool for Python. But what people end up doing is they write tests using PyTest as an executor, and then it will either twiddle GPIOs or it will send serial console commands to a hardware device under test. There are even Python modules for interacting with National Instruments equipment or other types of, like analog sensing or power supplies or whatever, right? So it kind of becomes a Swiss Army knife again of like ways to build tests, but then pairing that up with some kind of execution tool is typically the stack that we see people just kind of naturally tending towards. So if you're looking for how to start on Hill, that would be my suggestion. All right, one more. One more, I guess, comment from Vivek, who's in India, just saying thanks. So yeah, you bet. Thank you so much, Vivek, for joining us too.
Okay, well, right. I'll give you a chance to close, Joe. I'll close with just saying thanks, everybody. As you go through your journey, think about the people too. That's really what I was trying to get in here that I see missing, in my opinion, in a lot of discussions about CI. So think about other people and their workflows and making sure you're getting them onboarded in a good way.
And feel free to reach out if you got any questions, hit any stumbling blocks. You won't get a sales pitch from us. Our goal is to push forward, no matter what. So be great. Thanks so much, guys.